into it.
Okay, John, today we are going to talk about the two diverse experiences that math educators bring to the classroom. And I think that it's actually perfect that you and I are doing this episode together, because I think that we represent these two diverse experiences.
Okay. What do you mean diverse experiences? Give me the lowdown on what you're meaning here.
So I know that for you, you are obviously a secondary math educator. You went through school to focus on math. Math was probably the subject that you excelled in.
I loved it.
Right. And it was probably pretty easy for you. And you probably found that the way that math was taught worked for the most part.
Yeah.
Like there's a reason that you chose it as
I was a
memorizer.
I was a memorizer, and I got a lot of satisfaction of like memorizing and then regurgitating. And it was like I loved that part about math, right? It was like, oh, I can follow this pattern, because that's what really everything came down to for me. It was like I could follow this pattern quickly, and then I could use that same pattern to solve this other pattern over here, or this problem over here. I was never a great problem solver. I was always like I can follow this procedure, and I can then recreate that procedure over here, and I get a pat on the back when I do it right.
Well, and I was the complete opposite. I always describe it's like math was like mud to me. Like it's like they might as well have just like smeared the entire chalkboard, because none of it made sense at all. And I can't memorize that way. It's like if without meaning, it will not stick for me.
Right.
And so I even remember being in elementary school and being taught the formula for area, which to me now is like such a simple concept. But man, it's like I could not remember it. And on top of that, I didn't have any fluency.
Right.
I had no operational sense. But then imagine, we both end up becoming math teachers. So
right.
You're secondary math, and I taught mostly, junior intermediate. So grade 6 and 7 predominantly in the classroom.
Right. Yeah. So I was just going to say, like you're highlighting our backgrounds, right? So it's like I came from the secondary. I have a math degree. I went to do all the school for math. You're an elementary teacher. We're both teaching math now. But let's talk about like the two dynamics here, because like everyone in different buildings has a version of this, right? You've got that math focused teacher, whether it's in elementary and they're teaching grade 8 or grade 7, and they're like, yep, I'm the very procedural math teacher, because I taught like that for a very long time, like my first 10 years, very procedural, taught the way I was taught. Most of us did, right? Most of us do, except for you. And then, you've got kind of that, I follow the procedures. This is the be all end all, is like, let's make the procedure, the mimicking, the getting it out, that was what math was for us and for me. And this is how I learned it. That's, there are people in your buildings like that, and they will stick to the, math. Speed is a factor of math. Accuracy is the most important part of math. Getting the way to write it down this way is the most important part of like doing well in math class. But then you also got teachers in your building like you, who are coming at math from, I never understood it. I'm really trying to understand the conceptual, because I'll admit I was never bothered by the understanding of like why this worked and why that didn't work. Like I never remember asking those questions when I was a student. So it's like you've got that experience coming in. Like I want to make sure everything makes sense for me so I can make it make sense for kids. And that's a priority in your world, which might not be the priority in that other teacher's world or my world for their first 10 years. But what we're saying, I think what you're want to make here and what we want to talk about here is that we need both in a way. Like you need to kind of like, in a way, have both, but like you need to rely, like each of those two different people need to rely on each other.
That's exactly it, John. It's like we are a perfect match, and people might be surprised to hear that like somebody like me who had, a very, let's say, challenging math experience as a student, who now you summarized it perfectly. It's like I cannot teach math without understanding it. And so therefore I create an experience for my students that's rooted in understanding. It's like, we're going to build it. We're going to see it. We're going to use context, because if it doesn't make sense, there will be no retention for me. And I imagine many of my students.
I was going to say that makes sense. Like now this is just because I've grown to know that these are important things to have in our classrooms. So when you think about it, like, and I think everyone listening right now, is nodding their heads being, I want that for my students in my classrooms. Like, they've been striving towards having, creating sense making, for their students in a different way than they learn math. So why does it make sense that you should go and find someone who was like me as like an important part of your learning as a teacher?
It's a great question. So at the end of the day, and this is not my idea. This is from Kathy Fosno and leveraging a lot of Kathy's resources. But at the end of the day, after we've engaged in these rich tasks and we've made sense of mathematics and we've represented it and we've used context, we still have to formalize it. Like the teacher is the one who is responsible for connecting the mathematical representations. So I have to take what we did, what we acted out, what we drew, what we modeled, what we, how the math behaved. And I'm the one that actually guides the students to the formal representation or the more procedural representation. And this goes back to the debate, right, between conceptual and procedural. Of course, you and I both firmly believe you need both. It's not enough to just conceptualize math, and it's not enough to do a procedure. The actual strength is in the connection of the two. But my problem is and maybe this is also my gift. Kyle actually used to joke with me all the time. My problem is I actually don't know the procedure. I don't know the rule or the trick. Like if you tell me.
And I didn't know the conceptual.
Right. And so what I would often do is I would have to, particularly when I was in the classroom and even in other roles, it's like I could make sense of something. So I would, solve the problem in the ratio table or on the number line or in an array. But then I would go to somebody like you and I would say, okay, now, John, show me how to solve this algebraically. Because I need to take my representation and match it to your algebraic thinking. Mm-hmm. And both pieces are really critical to support student understanding.
Totally. That in our opinion, in the work that we're trying to do is like, that is the math that we want to learn, is that connection. It is to say, we have the conceptual, we're going to move towards the procedural fluency. Both are equally valid and not one is weighted more than the other. And I think when we think about conceptual understanding, if we're in that, say, wanting that for our students, we put a lot of emphasis over there. And if I'm the very procedural teacher, I put all the emphasis over here. But we want to make sure like that there's that balance between the two, and you have to, and the power is connecting the two. Like that's the teaching that has to happen. And that's the learning, the outcomes really that we need to help students make, is because if you think about it, like we can't have students just always drawing this over here and like taking, say, a long route to get to a particular answer. Like we want them to get closer to that procedural, because the representation of that abstract representation, because there's power in the abstract representation that you can't always have in the conceptual, and vice versa is true as well. And it's like think of it, the history that math was developed was probably rooted in the conceptual anyway. And we moved it towards procedural because it allows us to move quickly. It allows us to like represent our thinking in very standardized ways that other people can see and understand and make sense of, because they also have that same standard of representation. Like there is power in say, going to this abstract representation, but very much power in the conceptual. So both need to be matched. And I think you're right. Like having it shown to you is allowing you to like make those connections. And this is the same, it needs to be true for that person who's, very procedural. And I think a lot of us listening right now work with the people who are very procedural, and we would love for them to have like this conceptual understanding. And then we want to make like, it would be great to have that person. It's like, hey, the two of us are going to kind of join forces and bounce different ideas off each other to see, what are you doing conceptually? How do I link it to procedural? What are we doing procedural? How do I link it to conceptually? Like, I think there's a lot of effort to go one route right now because there's a lot of procedural teachers out there, and we're trying to bring the conceptual to them. And versus vice versa, because more people have the procedural than the conceptual, I would think.
So how do you develop the conceptual? Like, I mean, so you've shared that that was part of your journey, right? Is that you started really strong procedural and you didn't really have the understanding. So what worked for you?
What worked? Oh yeah, what worked for me? I think it was specific PD trainings that allowed me to have, say, witness what this could look like when I understand it and when my students understand it. Like, it's not something that I just stumbled across, because I actually used to gloss over it. I used to be the teacher, and there's a lot of teachers still like this, is that the core resource that we were using, when they shifted, when I was teaching, say, I think it was ninth grade, there was algebra tiles and area models all embedded in that core resource for multiplying binomials. And I used to skip over that and go, I'm just going to show them the right way to do it, because it's quicker if I do it this way. And to me, my philosophical approach back then was math was about getting to the standard algorithm, was like getting to this procedure so that we can do it. Like, and use it when we're solving problems. So it's like, well, why not just go right to it? Like, if I can show you clearly. And to me, teaching back then was about how fast could I get you to understand that, or get you to follow that. Like, if I can explain this very, very clearly and step by step, I was a really great teacher, right? Like, that was my goal. And I think that's still the goal of many, many teachers. So when I was put in positions of representing that in different ways, or seeing the power of, like, it modeled well for me, and I could see my own feeling of, like, I saw like, when it was clearly pointed out, the connection between the area model and multiplying. That's when I'm like that's, we call that the math epiphany. Like, it's a math epiphany where I'm like, I did not know that thing that was in that core resource, that textbook that I used to skip over, that's what we were talking about. Like, I used to just think, what is that? It's just like and this is what teachers still say. Like, that's a tool for kids who can't go quickly into the algorithm, which is not the case. But when I felt it, and I felt that power of, like, oh my gosh, like, it doesn't matter if I do it in this order, it doesn't matter if I draw it this way, or like, you got the flexibility of this connection. When we teachers have, say, I guess in a way, an emotional response to, like, something, that epiphany, that's when you usually switch from one side to the other, or you switch to saying, like, I'm now going to use this because I can't unlearn it.
And, I'm going to be very honest. I certainly didn't come into the profession with conceptual understanding either. I had neither.
Right.
So I didn't have conceptual understanding, and I didn't have procedural fluency. What I had was math anxiety, and I'm just a negative, I had a poor sense of my own ability in mathematics. But what I did have, I guess, the strength that I brought was recognizing that I needed to do something different than what I had experienced. Like, I knew that wasn't good enough for kids, and I knew that I would be leaving kids behind if I just followed the textbook and modeled and had them mimic. So my big moment was, I attended a PD. It was actually with Kyle at the time. And I learned about the math proficiencies, and I've shared this before. And I walked away from that session realizing that math was visual, and that math could be seen and manipulated in your hands. And it wasn't just this, symbolic, confusing representation. And so for that first year, we made a commitment, my teaching partner and I, to represent every single concept concretely, every one. And it's like, if we couldn't represent it concretely, that meant we didn't understand it, and we had to seek outside consultation from somebody who did. And that was like, we committed to ourselves and we committed to our students that and it evolved from there. Like, I realized later that, some concepts aren't great concrete, fractions, for examples, are better with pictorial. And so obviously my understanding of visual representations evolved over the next few years. But that commitment to ourselves and to our students, that we would follow, the concreteness fading model, was the shift that I needed to build my own conceptual understanding, which then was almost like the catalyst for all of the change that I made in math instruction.
And I think the important, like, regardless of, like, that impact that you had on yourself and your learning, I think the real, think about what Yvette has just said. It's like, I made a commitment to always doing this action. And that right there is is like the gateway to like change in my opinion, because I remember like I've said those words in different ways throughout my career, and every time it made an impact. Like early in my career, before I had that conceptual understanding, like I remember someone handing me the TI calculator, and it was like, this new calculator is going to be great for kids to explore, how transformations work with parabolas and quadratic functions and any type of functions, because the TI Inspire had like engaging techniques, and I'm like, that thing, it looks like it's so confusing to use. And I remember saying like, I'm just going to commit to every time I'm going to do something on a calculator, I'm going to use that calculator. And that was like my first couple of years of teaching, and then it became normal. It became part of like your routine. And so there, like, that's one example. But I mean, like every time I had a similar experience when I realized the power of the number line for proportional reasoning and solving proportions. And I taught high school, right? So it was like, every time we are solving a proportion, I'm going to represent it in front of the students on a number line so that we can see how, say, the scaling works and see how the additive and multiplicative relationships exist on the number line. And it was a commitment that I made to myself to say, I'm going to do it, which means I had to like know it before I could do it in front of my kids. And I had to feel confident that I knew what I was kind of thinking about and trying, so that I could show the kids and explain it when we needed to explain it. But it's like every time I know that I had that epiphany moment, or that kind of shift in my teaching, it was when I said those words you just said, which is like, I'm going to make a commitment to always do this. And I think that is the huge kind of movement maker when it comes to educational growth.
Yeah. And I think that, kind of going back to the start of the conversation, that journey for me where I said to myself, I'm going to commit to representing every single concept, that helped me with my conceptual understanding, but it didn't help my procedural fluency necessarily in a more, let's say, formal or symbolic way. And that's where I had to leverage the expertise of other people in my building. And I remember vividly, I had this epiphany. I was representing something either concretely or visually, and I knew that it worked, and I trusted it, and I'd made generalizations, but I didn't know how it would be taught formally, or I didn't know how to represent it symbolically, or what the steps would be. So I remember going to, a grade 8 teacher in our school to basically say, okay, can you show me how you would solve this symbolically? And I needed that. Like, I needed that bridge between what I had conceptualized and understood and that formal. And we talked earlier about, has anybody ever, you can probably picture this person, who, again, strong math background, confident in their ability to teach math, very efficient, knows the procedures. Like, I needed that person. But what that person maybe didn't realize at the time is that they also needed me. Like, if we're talking about creating accessible experiences for all students, if we want to shift from being gatekeepers and saying only some students should have access to higher levels of math education, then, I needed that grade 8 teacher. I needed him to show me how to formalize this or represent it algebraically. But the time we spent during nutrition breaks, he probably didn't realize he also needed me to show him symbolically or in the visual.
Did that materialize into any you showing him, or was it a one-sided I think kind of conversation?
I probably benefited
I can imagine.
more. I probably benefited more. But even the fact that, we always say, anytime you do math with others, taking time during your lunch break or during, any prep period where you're just literally standing side by side with another adult solving math problems is time well spent.
Agree.
Like, there's no more powerful professional development opportunity than just solving math problems together. And I think it's even more powerful when you actually bring people who are coming from the opposite ends of this experience.
Yvette, is that the big takeaway you want?
I think so, yeah.
To take away today?
For sure. We say this all the time, but, we're going to be more specific today in the find your people, and don't just find like-minded people or people that share the same experiences or strengths that you do, because that's helpful. It's helpful to find people who are going on the same journey that you are.
Sure.
But there's actually tremendous value in finding the opposite person.
That's how you grow. Like, I think you get tested. You get to test and get tested on the things that you have beliefs on, which are important pieces of growth. I just before we hit record here, I said a kind of, I guess it's a quote or a phrase or a statement that I think hits home, hits well here is that we should have strongly held beliefs but loosely held, which is like I believe this to be, if I believe this to be true, then I strongly believe it. Like if I strongly believe that conceptual understanding is the gatekeeper to math understanding, then I'm going to be like, I'm all in. Let's do this. But then and why we say loosely held is because the moment you have new evidence that says maybe this thing over here might be the better approach, then we should consider it. We should go, how does that blend with what I know to be true? How does that blend with, my current understanding of this particular topic, this particular idea? And does it hold any weight? And should I bring that into my thinking? Because that's where we grow, is when we start to think about new ideas and how they influence the things that we already know to be true or non-true. And we can be strong in our beliefs, but we need to be ready to be like adjust if we have new evidence that present it. So, that's a growth mindset type of thinking. But that teacher who is probably that teacher that you were talking with was strongly held beliefs, but strongly held. And that's a scary thing to be, right? Is that I always believe this and I'm never going to waver, even when I'm presented with evidence that maybe this is say an alternate strategy that can have more of an impact in, say, whatever field we're talking about. Because this is not like, that phrase isn't just a math phrase or a math teaching phrase. This is everything, right? So it's like, do I waver or do I adjust my beliefs if I have new evidence that support otherwise? That's why you want to have them loosely held, because if you strongly hold them, then you're basically saying, like, I'm never going to switch my thinking here, and even though it's staring me in the face.
And I guess just to conclude here today, like, why does this matter? Like, why is this work important, and why should we be striving to build up wherever we're lacking? Like, is it your conceptual that needs to be strengthened, or is it your procedural that needs to be strengthened? Like, why do we need to engage in this work? And I'm going to give you a personal example of why this matters to me. I think we can all agree, and I'm sure all of the listeners today agree, we want students to have a productive, like, I don't want students to say math is the class they hate. Like, I just don't want that for them. Like, I want them to see that math is interesting, and math is positions you to be a problem solver, and that they're capable. And I'm going to give you a perfect example. So my son, who's in grade 5, is working on patterns right now. He's working on linear patterns. And he had, a very standard growing linear pattern. The pattern was 3, 6, 9, 12, 15, 18. He was asked to write the pattern rule 2 ways. And the first one said, write the pattern rule using addition. And so he said, okay, start at 3, add 3 each time. The second question said, write the pattern rule using multiplication. And he got this one wrong. Okay. And he said to me, I don't know, I was overthinking it. It's just multiply by 3. It's like 3x. Like, I should have known that. But this is how he interpreted it. He looked at the relationship between 3 to 6 to 9 to 12 multiplicatively. So he was like, multiply by 2, then multiply by 1.5, then multiply by 1 1/3, then multiply by 1 1/4. Okay, because he understood the multiplicative comparison between the numbers in the pattern.
Nice.
Can you imagine, though, like, if I had a very procedural teacher who was coming from your end of the spectrum? Wrong. Right. Wrong. But in reality, like, amazing thinking for a 10-year-old, that he was like, I need to look at this pattern through a multiplicative lens. He wasn't, of course, like, he wasn't thinking the relationship between X and Y. He was looking at the values of Y and he described how they were being multiplied. And so there's two experiences he can have, and this is just one kid. He can be told he's wrong and get a 0, and that's it. Or his thinking can be valued, and that will affirm his identity as a mathematician. But in order to be positioned to affirm student thinking, to help them be thinkers and critical thinkers and see themselves as that, like, math is about making sense and seeing relationships and reasoning, we have to be positioned to see it.
Mm-hmm.
And if we don't see it, math class becomes very black and white for kids.
Very much so.
Right and wrong.
It's the belief we have about what math is and what math class is versus, I guess that's it. It's like, what do you believe to be true about the experience you're providing? Like, what is it that you're trying to do in that class? Because my first 10 years, I was probably that teacher that would have marked that wrong, because I held strongly, I had strong beliefs and I strongly held them about what math was. And math was about doing, I taught you this, and now you need to show it to me over here. And hey, Leto, why wouldn't you know that I meant, 3x? Come on. Like, I went through example 1, 2, and 3 already, and it's like, because you have these like beliefs of like, this is what it's supposed to look like. This is what I'm looking for. This is the answer. Otherwise you're wrong. Like, that's a strongly held belief, strongly held.
Yeah. So, this is why the work, right? This is why we have to take the time to strengthen both our conceptual and our procedural. And I think that,
and our mindset, like
and
think
our
about
mindset,
like that,
for
that
sure.
Right there. It's like, if I, in a way, here's another, one of our big takeaways here is like, everyone should find someone with the opposite viewpoint and try to learn from them. So you're actually going, I have strong beliefs, but I'm loosely holding them, and I'm going to learn from this person, and they have something to teach me. And if it's a mindset shift about what you're doing in your math class, then find that person who has the opposite mindset and have that conversation. What are they doing in their class, and what can you pull for your experience to help with your students? And then maybe they also have some of that open-mindedness at that point to have that, say, get that next step from you, even though that experience for your example before wasn't the case. That teacher wasn't looking to learn anything from you. You learned from them, and you needed to take what they had and apply it to your learning. We can do that with mindsets as well, other than just conceptual understanding to procedural fluency.
I think if we can do this work, if we can find these people, if we can learn from each other, then we're going to avoid the math wars or these big debates, because none of it is black and white, and none of it is all or nothing. Like, of course we need students to know their facts, and we need them to demonstrate fluency. Of course we want them to be able to be efficient and generalize and use algebraic representations. Of course we do. That's the goal. But that doesn't mean that we have to do that by relying solely on memorization, because we just know that, like me, it's not going to work for everybody. We're not going to reach as many students if we focus on this one approach that worked for, let's say you. We just know it's going to leave out so many students. So can we get to the same result, but in a way that's going to create a more equitable math experience for all learners, that's rooted in understanding, that's going to support retention?
Love it. Find your people, folks. Find those people that are not your people. Both of those are the messages here. It's hard work to do that. You have to put yourself out there, but also you have to be ready for that person who isn't going to be part of that conversation when you need them to be or want them to be. These are some of the big takeaways we're hoping you have going forth and doing the great work that you're doing in your classrooms. Let us know. Well, what was your big takeaway from this conversation that Yvette and I just had here? Let us know. You can reach out to us on all social media platforms at Make Math Moments. You could hit reply on our email list. We're probably sending you a few emails throughout a week or every couple of weeks. Hit reply. Let us know, what is your big takeaway from this particular episode, and we would love to hear from you about that.